Rule for exponents, and this is a pretty easy fold. Like I said, you just fold it until you can make sure you just don't cover up the title. All right, so we're going to start with a power to a power. So basically, a power to a power means when you have a power on the inside, exponent inside, and an exponent on the outside, then you're going to multiply the powers together. Okay, so you should have this. To raise a power to a power, you keep the base and you multiply the exponents. So here's a power to a power, so we'll just apply the rule. We'll multiply 3 times 4, x to the 12th power. Number 2, power to a power, multiply m to the 35th. Okay. Then we have a power to a product, because now you have more than just one term inside or one variable. So if you have multiple things inside, then each thing has to be raised to that power. So as we know, every variable has an exponent. If it's invisible, it's 1. And every number has an exponent, which is 1 if it's invisible. So it says to do this, you're going to raise product to a power. You're going to raise both factors to the power and multiply the exponents. So it's almost like doing the distributive property. So here I have an f to the 3rd and a g to the 5th. So I'll take this power that's on the outside and multiply by both. And you get f to the 21st, g to the 35th. So remember I said every number also has an exponent. When it's invisible, that exponent is a 1. So this is like 4 to the 1st, r to the 2nd, s to the 9th. So again, we'll take this outside power and we're going to multiply it by even the one that has the 4, which is a 1. So 4 to the 3rd, okay, that's going to give us 64. And then we'll multiply 2 times 3 and 9 times 3. All right, so here's number 7, same thing. This 2 has a power of 1, so we're going to say 1 times 5 is 5. So when you raise 2 to the 5th power, you get 32. And then you have your 4 times 5 and your 3 times 5. Okay. Now, when there's a negative, and of course this also has to the first power, you want to make sure that you're raising that in parentheses, okay, because this is in parentheses. So when you say -5, all of that raised to the second power is 25, okay, because there is a difference when the negative is not in parentheses, but this is in parentheses. So please just be careful. You are taking everything and putting the power on the outside, so you're including the negative. All right, so now what happens if you are doing the power to a power and it's a division problem? Okay, so again, everything inside will be multiplied by that power on the outside. So the invisible power again is 1. So it says to raise a quotient to a power, you raise the numerator and denominator to the power by multiplying the exponents. Okay. So now we have a division problem. We don't see any exponents inside, but when they're invisible, it's 1. So you just have x to the 6th and y to the 6th. When you also have a 7 and a variable, everything again has to be multiplied by that outside power. So 7 to the 2nd power is 49. And then you have your b to the 2nd and your c to the 2nd. All right, now I'm going to add a couple of things. So because what happens if you have, let's say, and you could add this either in your notes or in your spiral, it doesn't matter. Okay, but let's say we had something like 3a to the 4th, b to the 2nd, and let's say I have a to the 6th and b. And now I'm going to raise this to the negative second power. Okay, because we can have your outside powers can also be negative as well. Okay, so there are a couple ways you can do this. You can simplify what's inside first and then multiply it to the negative second, or you can just go ahead and multiply that out, okay, completely, and then make the changes later. It's totally up to you. So if I raise 3 to the negative second, and of course I know I cannot leave negative exponents in my answer, so later I'm going to simplify that. And I keep on multiplying, I'll get a to the negative 8 and b to the negative 4. So all I'm doing is multiplying this negative 2 by every exponent inside. Do the same thing to the bottom. So this will be a to the negative 12 and b to the negative 2, okay, because this is a negative. So I want to simplify this. So first, I'm going to drop this down to the bottom because I want that to be 3 to the positive 2, which will give me 9. Okay, because so now we're kind of implementing some of the other rules along with this power of a power. And then when I subtract my exponents, because now I have a negative 8 really plus 12. And what is negative 8 plus 12? Because minus a negative is plus. So what's negative 8 plus 12? 4. So that's a positive 4. So that's going to go at the top. And then I'm going to have negative 4 plus 2. Because again, that's negative 4 minus a negative 2, which is negative 4 plus 2. And that's going to give me what? Negative 2. So I'm going to put that down here. So take the reciprocal, so it'll be positive. So once you start incorporating more than one rule, you got to, recall what do you do when now you have a division problem and you have the same base at the top and the bottom. We know we subtract. What happens if you subtract and it comes out negative? You have to take the reciprocal to make it positive. Okay. All right, so let's do another example. So let's say we had something very simple, 1/9 to the negative 2 power. Okay, if we have 1/9 to the negative 2, okay, I can just, since I already know both of these are going to end up being negative exponents, I can just do this, 9/1 to the positive 2. So I just flip the whole thing at the same time. Okay, and so what will that give me? 81. That's your answer. Okay. Let's take another one. So let's say we had z to the 5th over z to the 2nd. And then I raise that to the negative 4th power. So if you wanted to, you could actually just simplify the z to the 5th over the z to the 2nd right away. So I could just say, okay, 5 minus 2 will give me 3, and then raise that to the negative 4. So that's going to give me z to the negative 12, which then I take the reciprocal, and that's going to give me 1 over z to the positive 12. Because again, you cannot leave negative exponents in your final answer. You have to take the reciprocal. Okay. So for classwork today, if you look at your calendar, it says you're going to be doing pages, what page do we have? 10 through 13. Okay, so you'll be doing 10 through 13, and you can see for the break, I'm not assigning you any homework.